Lesson 5.6 on Review Packet 5a. Graph each function. X maps to 4x plus 9. Okay. So, we know. So let me do part A. So 4x plus x maps to 4 times x plus 9. Right? If x is 0, then it will be 4 times 0 plus 9, which is 9. So the coordinate pair will be 0 and 9. Likewise, 1 maps to 4 times 1 plus 9, which is 13. So coordinate pair will be 1 and 13, right? Because this is linear function, because you see you don't have any square or anything, you don't have any power on x is really clean. So this is a linear function. Linear function, if it's a linear function, all we have to do is just to find the 2 points and connect those two lines with a straight line and extend it. That's all we have to do. So that's what I'm going to do here. Let me just draw, let's say this is my x-axis and this is my y-axis. Obviously I don't have 13 on that square, so I'm going to skip count. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Likewise I do that. 2, 4, 6. Okay. So my first point is 0 and 9, so let me just plot the point. 0 and 9 right there. 9 is between 10 and 8. And 1, 13. So my 1 is in the middle of 0 and 2 and go up there, so it's be there, right? And then just draw a straight line, right? Yeah, something like this. This will be my graph. You can, the next one will be a little different because this is a quadratic function. This is not a linear function, so you need more than 2 points. So make sure you find, probably if you use 5 points, it will be great. For C and D, this is a linear function, even this is fraction, right? As long as if x is on the bottom as a denominator, then that's a rational function, so it will be a little different. But x is on top of it, which is a numerator, so it's a linear function. So all you have to do is find the 2 points. But the B, you got to be really careful because of this square sign. So let me take this one. Maybe that's not really. Okay, so let's do what she said. So she said, okay, this is the graph, and let's draw y equals x, right? Y equals x is this. 45-degree lines, right? And the intersection is -6, -6. Does it fix is the point? Is that true for this? Well, let's try. It's -6. If x is -6 in this case, that's going to be 4 times -6 plus 9, which is -24 plus 9, which is -15. So it doesn't really fix it. So this doesn't fix on this case, but how about the other case? So I want you to do that. Okay? Problem. Elaine explains how she finds fixed input or inputs that remain unchanged by a function. Let's say you want to find a value fixed by the rule x maps to 4x minus 9. First, graph y equals 4x minus 9. Then graph y equals x. The graphs intersect at 3, 3. See, the rule x maps to 4x minus 9 fixes the value 3. Use Elaine's method to find a fixed point for each function in exercise 8. Does her method work? So her method is, if you have a function like this, just graph that, okay? And then graph this one, okay? And then find the intersection points, okay? And then it says the rule of the original rule fixes the value 3. Is that true? Well, that works for this one, but I'm not sure that will work for other one. So it says that it fixes the value of 3, right? So just try that one and to see if what she said is true. Okay, next problem. Is this it? Alright. If this is it, I will do the other problem. What was the other problem?